the determinant of matrix. In this video, we're going to look at determinants of matrix. The determinant of any matrix, say B, or say matrix B, is denoted by a symbol B or DETB, where the ET is the short form of determinant. It's a number calculated by the format below, depending on the order of the matrix, that is 2 by 2 or 3 by 3. If the value of the matrix determinant is 0, then the matrix is called singular matrix. Otherwise, it is non-singular, and it is only non-singular matrix that has inverse. That means to say that non-singular matrices have inverse. So when we see a singular matrix is if say the matrix is E11, E12, E21, E22, and by the time we look for the determinant of A, matrix A, we're going to have A11 times A122 minus A12 times A21. Well, multiplied. Let's say we got B. Let's say we got an answer. Let's say we got B minus C. The result of A11, A2 is B. The result of A12, A21 is C. And if when you subtract C from B, your final answer is 0, meaning that the determinant of matrix A is 0. So any matrix whose determinant is 0 is called a singular matrix. It's called a singular matrix. That's the implication. So yes, it says if the value of the matrix determinant is 0, then the matrix is called singular matrix. Otherwise, it is non-singular, and it is only non-singular matrix that has inverse. So after this video, we're going to look at inverse matrix. So that's the implication, only non-singular matrix that has inverse. So let's look at 2 by 2 matrix determinants. We have 2 by 2 matrix determinants and 3 by 3 matrix determinants. As you can see here, it all depends on the order, whether 2 by 2 or 3 by 3. But we're going to start off with looking at 2 by 2 matrix determinants. So given that A is equals to A, B, C, D, that means matrix A has A, B, C, D as entries or elements, then the determinant of matrix A is simply AD minus BC. What it implies that you go diagonally, A multiplies D, B multiplies C, and then you subtract the product of BC from the product of AD. So that's how you get the determinant of matrix A. So example 1, if A is equals to 3, 1, 4, 2, find DET determinant A, or determinant of matrix A. So solution, determinant of matrix A is equals to 3 times 2, we come this way, as give us 6, and then BC, 4 times 1 minus 4, which is equals to 4. So you subtract the product of BC from the product of AD, which is 6 minus 4, and that will give you 2 as the answer. And this implies that 2 is the determinant of matrix A. Take another example, example 2. If D is equal to 2, 6 minus 1, 4, find D. Like I said, this symbol means determinants. So that's what we have here, and same thing here. To find determinant of matrix A, the solution 2 times 4, they're coming this way diagonally. If you do it like this first, 2 times 4 is going to give you 8, and then 6 times minus 1, which is BC, 6 times minus 1 minus 6 included in brackets. So you're supposed to subtract, but now that you have minus 6, you're going to simplify this first. Minus x minus 2 give us plus. So 8 plus 6 is equal to 14. So this implies that 14 is the determinant of matrix D. So this is how we carry out matrix determinants on 2 by 2 matrices. So we're going to take further examples, and that will really show clearly how we solve problems relating to 2 by 2 matrix determinants. Number 1 says, which of the following matrices is a singular matrix? Which of the following matrices is a singular matrix? For us to be able to determine out of these options the singular matrix is to find the matrix here that the determinant will equal to 0. So let's try them one after the other. The matrix E, let's see option E. E that's that 1 0 0 1. So let's say determinant, let's call it okay, let's say option is matrix E. The determinant E is equals to 1 times 1 is 1, 0 times 0 is 0. This will give us 1. So can it be, let's check option B and call it matrix B. So matrix B is 2 3 1 2 2 3 1 2. So the determinant of matrix B is equals to 2 times 2, 4 minus 1 times 3 is 3, that's equals to 1. And let's say matrix C is 3 8 6 16. So determinant of matrix C, 3 times 16 is 48. 8 times 6, 48. That's equals to 0. D, matrix D is 0 1 1 0. So the determinant of matrix B is equals to 0 times 0 0. 1 times 1 is equals to 1. So 0 minus 1 is minus 1. Well, from our definition earlier, we said that once the determinant of a matrix is equal to 0, then that matrix is said to be a singular matrix. So from what we have here, matrix A is 1, determinant of matrix A is 1, determinant of matrix B is 1, the determinant of matrix C is 0, and the determinant of matrix D is minus 1. So matrix C is a singular matrix because the determinant of the matrix is equal to 0. So option C is the answer. Number 2, if x is equal to 5, so we don't represent x, find x. The matrix is not, don't represent the matrix with small letter, is capital letters. But if x is equal to 5 minus 2, 3 minus 2, find the determinant of x. So x is equals to 1, 5 minus 2, 3 minus 2. So the determinant of x is equals to 5 times minus 2 minus 3 times minus 2. 5 times minus 2 is minus 10, minus 3 times minus 2, minus 6, minus 10, minus times minus plus 6. So minus 10 plus 6 is equals to minus 4. That's the determinant. Number 3, evaluate 2 4 1 6. Once you see matrix enclosed in brackets in this form, it means determinants, look for the determinants of that matrix. So matrix 2, 4, 1, 6 is equals to 2 times 6, 12, 1 times 4, 4. So 12 minus 4 is equals to 8. That's the answer. If this matrix is equals to this, and what it means that if the determinant of this matrix is equals to the determinant of this matrix, find the value of x, which is what we have here. 5, 3, x, 2, equals to 3, 4, 5, 5. The determinant of this matrix is I times 2, I times 2, minus 3 times x equals to 3 times 5 minus 5 times 4. I times 2 is 10 minus 2x, 15 minus 20 minus 3x plus 15 minus 20 minus 5 is 10, 10 minus 3x. So this will just minus 3x plus 10 minus 5 minus 10 minus 3x plus minus 15 x equals to minus 15 minus 2 minus cancel out 2 so 3 1 into 15 5 therefore x equals to 5. So number 2, if 3 minus x minus 1 9 1 plus 2x is equals to 0. So this is a singular matrix because the determinant is equal to 0. Find the two possible values of x. So this multiply this. That's 3 minus x 1 plus 2x minus 1 minus 9 or 9 times minus 1, so the same thing. Since b applies 9 times minus 1 equals to 0. So our bracket is 3 times 1 is 2, 3 times plus 2x is plus 6x, minus x times 1 is minus x, minus x times plus 2x gives us minus 2x squared, minus 9 is equal to 0. Minus 9 is equal to 0. So 3 plus 6, 3 plus 6 plus 6x minus s will give us plus 5x. 3 plus 5x minus 2x equals 4 minus 2 squared minus x minus is plus 9 is equal to 0. So 5 okay minus 2x squared plus 5x plus 2 plus 9 is equal to 0 minus 2x squared plus 5x plus 12 is equal to 0. To multiply all through by minus 1, multiply all through, multiply through, minus 1, so that the coefficient of s squared will be positive. By minus 1 will be minus 1 minus 2x squared plus 5x plus 12 equals to 0. So minus 1 times minus 2x squared will give us 2x squared. Minus 1 times plus 5x will give us minus 5x. Minus 1 times plus 12 will give us minus 12 equals to 0. Now we have a quadratic equation to solve. So we're going to come back here and say 2x squared minus 5x minus 12 That's a 0. So multiply the coefficient of x squared and the constant 10 together, which is AC. 2 times minus 1 will give us minus 24. So two factors of minus 24, or two factors of 24, that when multiplied together will give us minus 24, and when added will give us minus 5x. Let's get the factors of 24. 6 times 4, 12 times 2, 8 times 3. 6 times 4 will give us 24, and 6 plus 4 minus 1 will give us minus 5. What we do is that we're going to work with we're going to start adding signs to each of the factors to see if when we multiply we don't have minus 12, and when we don't have minus 5. So 6, let's say minus 6 times minus 4 or plus 4, because our side is negative. Minus 6 times plus 4 will give us minus 24. Minus 6 plus 4 will give us minus 2. Even if we put plus 6 minus 4, we're going to have plus 2. So, but here is minus 5. So we are not going to, this one is not going to give us what we want here. 12 times 2, let's say plus 12 times minus 2. Plus 8 times minus 2 will give us minus 24, plus 12 minus 2 will give us 10. What we have here is minus 5, not 10. And if we change the sign, we put minus 12 times plus 2 will give us minus 24. Minus 12 plus 2 will give us minus 10. What we have here is minus 5, it's not minus 10. So these factors will give us this quadratic equation. So the next one is 8 times 3. Minus 8 times plus 3 give us minus 24. Minus 8 plus 3 is equals to minus 5. So let's check. I think this will give us the quadratic equation. We have minus 12 here and minus 5. So we're going to put these two factors. So we say minus 8x plus 3x. So the two factors are, so we say 2x squared. We'll put these two factors in place of minus 5x. 2x squared minus 8x plus 3x minus 12 equals 0. So 2x squared minus 8x, then 3x minus 12 equals 0. And this will give us 2x, give us x minus 4. And what's common? That will give us 3 plus 3 give us x minus 4 as well, equals 0. So 2x plus 3, then since the two are the same, take one of them, x minus 4 equals to 0. So either 2x plus 3 is equal to 0, or x minus 4 equals to 0. So 2x is equals to minus 3, or x equals to 4. And x is equals to minus 3 over 2, or x is equals to 4. Therefore, x is equals to minus 3 over 2, comma 4. So these are the two possible values for this question. Number 3, if minus x minus 1 12 is equals to 12, find x. This means that if the determinant of this matrix is equals to 12, then find the value of x. So determinant here is minus x times 4 minus x times 4 minus 12 times minus 1 equals to 12. So this is equal to minus 4x. Minus 12 times minus 1 equals 12 plus 12. So minus 4x is equals to 12 minus 12. So, and minus 4x is equals to, so here's minus 12. Minus 12 minus 12 minus 12. equals to minus 4 minus 4 minus 12 minus 24. So x equals to minus 24 over minus 4. This will cancel out 4 here 1, 20, 24, 6. X is equals to 6. Number 4. Given that P is equals to the matrix 2, 0, 1, 3, find the value of minus 5p plus 6i. That is the matrix of the determinant of this matrix minus 5p plus 6i, determinants of the whole of this. So first of all, we're going to evaluate minus 5p. Given that p is this, minus 5p is equals to minus 5. So this minus 5 is a scalar multiplying matrix p. 2, 0, 1, 2. This will give us minus 5 times 2 is minus 10. Minus 5 times 1, minus 5. Minus 5 times 0 is 0. Minus 5 times 3 minus 15. That's matrix, or this minus 5p. The next thing we're going to do is plus 6i. Next, evaluate 6i. Remember that I is an identity matrix, so let me put I here. I is equals to 1, 0, 0, 1. Since this is 2 by 2 matrix, then it should be 2 by 2 square or identity matrix. So 6i will give us 6i is equals to 6, also a scalar multiplying matrix I. 1, 0, 0, 1. This is 6, 6, 0, 0, 6. So now evaluate minus 5p plus 6i. So minus 5p plus 6i is equals to the matrix minus 5p is minus 10, minus 5, minus 5, minus 10, minus 5, 0, minus 15 plus 6, 0, 0, 6. So this will give us minus 10, minus 10 plus 6, minus 5, 5 plus 0, and 0 plus 0, minus 15 plus 6. This will give us minus 10 plus 6 is minus 4, minus 4, 0 plus 0 is 0, minus 5 plus 0 is minus 5, and minus 15 plus 6 will give us minus 9, minus 9. Give us minus 9. So this is the matrix for minus 5p plus 6i. Next thing I'm going to do is to find the determinants of this matrix. You see, evaluate minus 5p plus 6i. So evaluate minus 5p plus 6i. That means find the determinants of minus 5p plus 6i, which is this matrix itself. Find the determinant of that matrix. So minus 5p plus 6i is equals to minus 4, 0, minus 5, and minus 9. This is minus 4 times minus 4 times minus 9 minus 5 times minus 5 times this will give us minus 4 times minus 9 gives us 36. Since minus times minus gives us plus, minus 5 times 0 is equal to 0. This is 36. Value is 36. If p is equals to x plus 2, x plus 1, x plus 2, x plus 2, x minus 1, evaluate x if p, that is the determinant of matrix p is equals to minus 10. So this way given the determinants will be minus 10. So it implies that 9 is x plus 3, x plus 1, x plus 2, x minus 1 is equals to minus 10. And this one. So let's determine, so this will give us x plus 3, x minus 1 minus x plus 2, and x plus 1 equals to minus 10. X times x is x squared. X times minus 1 minus x plus 3 times x is plus 3x plus 3 times minus 1 is minus 3 minus x times x is x squared. X times plus 1 plus x plus 2 times x plus 2x plus 3 times plus 1 plus 2 is equals to minus 10. So x squared minus x plus 3x will give us plus 2x minus 3 minus times x give us minus x squared minus x plus x minus, okay, let's simplify, minus x squared, to simplify here, plus x plus 2x plus 2x plus 2 equals to minus 10. So x squared plus 2x minus 3 minus times x squared is minus x squared minus times plus 3x minus 3x minus times plus 2 minus 2 is equals to minus 10. So we're going to like terms together. This will give us x squared minus x squared plus 2x plus 2x minus 3x minus 3 minus 2 minus 3 minus 2 is equals to minus 10 is equals to minus 10. So plus x squared minus x squared is 0 plus 3x minus 3x will give us minus x minus 3 minus 2 is minus 5, so it's still minus 10. So minus x equals to minus 10 plus 5 minus x equals to minus 5. Coefficient of x is minus 1, so x equals to minus 5 minus 1. Minus will cancel out, 5 divided by 1 is equals to 5. That's the answer for number 1. If 7x is 3x is equals to 24, find x. 7 times x minus 3 times x equals to 24. 7x minus 2x equals to 24. 7x minus 3x is 4x equals to 24. So dividing both sides by 24, x equals to 24 over 4, area 1 into 24 is 6. Therefore x equals to 6. Naturally, if 1 plus 2x 6 minus 1 3 minus x is equals to minus 3, we find the value of x. So this means determinant, or rather this bracket means determinant 4 plus 2x 3 minus x minus 1 times 6 so minus 1 times 6 1 times 2 is 2 1 times minus x 2x times 3 plus 6x plus 2x minus x minus 2x squared minus 6 equals to minus 3 minus x plus 6x minus 2x squared minus x minus x plus 6 equals to minus 3. Okay, so 3 minus x plus 6x will give us plus 5x minus 2x squared plus 6 equals to minus 3. So minus 2x squared plus 5x plus 6 plus 2 equals to minus 3 minus 2x squared plus 5x plus 9 equals to minus 3. Bring this one over here. Minus 2x squared plus 5x plus 9 plus 2 equals to 0. Equals to 0 because multiply through minus 1 minus 2x squared plus 5x plus 12 plus 2 0. Minus 1 times minus 2x squared gives minus plus minus 1 times minus 2 squared plus 2x squared minus 5x minus 12 equals to 0. So we have a quadratic equation to solve. 2x squared will come over here. So it's 2x squared minus 5x minus 12 equals to 7. Two factors. Okay, so x will give us minus 1224 minus 24x squared. So factors of minus 24 are minus 8 times 3 will give us 24. So here minus 8 plus 3 will give us minus 24, or plus 8 minus 3 will give us minus 24. So let's first of all let's just get the factors. 6 times 4 is 24, and 12 times 2 is equal to 24. Now out of these factors, which of them will give us minus 5, or which of them will give us 5 when added? So for us to get that, you can see if you add 8 and 0, you get 11. So the only way we can get 5 is when we put the sign, or when we start using sign alongside. So let's work with this sign. So let's say minus 8 times plus 2 will give us minus 24. Minus 8 plus 2 will give us minus 5. This is exactly, so we put our variable here x minus 24x squared, and 0 here will give us minus 8x, and plus 2x will give us 3x plus 2 minus 5x. This is exactly what we have here. So we put all of these. We put these two factors in place of minus 5x. This is minus 5x squared. So 2x squared minus 8x minus 8x plus 2x minus 12 equals to 7. 2x squared minus 8x and 3x minus 12 equals to 0. Now we factorize 2x plus 2x minus 4 plus 3x minus 4 equals to 0. 2x plus 2 and x minus 4 equals to 0. So either 2x plus 2 is equal to 0, or x minus 4 is equal to 0. x minus 4 equals 0. So 2x equals to minus 3 or x equals to 4. X equals to minus 3 over 2 or x equals to 4. Therefore, x equals to minus 3 over 2, comma 4. For the p, so y minus 2, y minus 4, y minus 1, y plus 2. And determinant of p is minus 2. We find the value of y. Okay, so since determinant of p is minus 3, so it means we're going to represent this matrix in determinant form. Y minus 2, y minus 1, y minus 4, y plus 2 equals minus 22. So let's look at determinant. Y minus 2, y plus 2, minus y minus 1, y minus 4. That's equals to minus 23. Y times y is y squared. Y times plus 2 is plus 2y. Minus 2 times y is minus 2y. Minus 2 times plus 2 is minus 4. Minus y times y is y squared. Y times minus 4 minus 4y. Minus 1 times y minus y. Minus 1 times minus 4 plus 4 equals to minus 23. So y squared plus 2y. Y squared plus y minus y is 0. Y squared minus 4 minus y squared minus 4y minus y is minus 5y plus 4 equals to minus 23. So let's close brackets. Y squared minus 4 minus times y minus y squared minus times minus 5y plus 5y minus times plus 4 minus 4 equals to minus 23. Y squared minus y squared plus 5y plus 5y minus 4 minus 4 minus 4 minus 4 is equals to minus 23. So this plus y squared minus y squared will cancel out and give us 0. 5y minus 8 equals to minus 23. 5y equals to minus 23 plus 8. So minus 23 plus 8 will give us 15. 5y equals to minus 15. So y is equals to minus 15 over 5. 5 over 1 into 15 is 3. So y is equals to minus 3. Over if minus 3 x 3y equals to 32. Find x plus y. Minus 3 times 4 is minus 2y. Minus 3 times x is 2x equals to 32. So let's continue. Since we have two unknowns, we're going to factor out what is common. It's common here between x and y. So that's minus 3 y plus x equals to 32. So y plus x equals to minus 33 over 3. Y plus x equals to minus 0, 2. And this is equal for x plus y. Therefore, y plus x So it equals to x plus y plus 2 minus 11. So t is equals to 7, 2 minus 3, 6. So find d raised to 1 over 2. This will give us the question 7 plus 6 minus 2 minus 3. 7 over 6 is 7 times 6 is 42 minus 2 times minus 2 times minus 0 is 9 plus 6. So this is equals to 48. So D is 48. The determinant of matrix D is 48. But D is equals to, but determinant of D, but D is a, so this is a determinant. The determinant of D is 48. D is equals to D raised to, but this should be because the final answer should be D because of D raised to power 42. This is 48 raised to power 42. And from indices, we're going to have, anytime you have x, fractional index, fractional power, it means is the square root of x. From indices, 48 raised to square root of 48, which is equals to 16 times 3. 16 times 3. And this will give us square root of 16 times square root of 3. Square root of 16 is 4. 4 times 3. That's 4 root 3. Therefore, D is 1 over 3 is equal to 4 root 3 as the answer. Number 4. You can see that number 4 will give us will lead to simultaneous equations. To solve the pair of equations x minus 3 y is equals to 8 and x squared minus 3 y squared 2 is equals to 7xy. So let's do this. X times 2 minus y minus 3 is equals to 8. X that's 2x minus y minus times minus 0 is plus 0y plus 8. Equation 1. So x squared times 0 will give us 2 x squared plus 2 minus y squared minus 3 equals to 7xy. 2x squared minus times minus is plus 3y squared equals to 7xy. This will give us equation 2. So now we have equation 1 and equation 2. So we're going to solve simultaneously. Solving simultaneously. Using substitution method. Using substitution method. So let's say from 1, make x subject formula, make x the subject formula, make x the subject formula, 2x plus 3y is equals to 8. 2x equals to 8 minus 3y. X equals to 8 minus 3y over 2. We call this equation 2. And substitute equation 2. Substitute put 3 in 2 in place of x. In place of x, in place of x in equation 2, 2 8 minus 3y over 2 squared minus plus 3y squared. 3y squared is equal to 7. 7y versus 7y. 8 minus 3y over 2. So now let's evaluate 2. Remember that 8 will come here. 8 minus 3y over 2 squared equals to 8 minus 3y over 2. 8 minus 3y over 2. So 8 times 8 is 64. 8 times minus 3y is minus 24y. Minus 3y times 8 gives minus 24y. Minus 3y times minus 3y is plus 9y squared over 2 times 2, 4. This is 64 minus 48y plus 9y squared over 4. So put all of this here. That will give us 64 minus 48y minus 48y plus 9y squared over 4 plus 3y squared plus 3y squared equals to 0y. 8 minus 3y over 2. 8 minus 3y over 2. So it's 2. So I need 2 here, 1 into 4. 2. So let's open our bracket to give us 64 plus 64 minus 48 y plus 9y squared over 2 plus 9y squared equals to, let's open this bracket here. 7y times 8 is 56. 56y. 56y minus 7y times minus 0y gives minus 21y squared over 2. Okay, so let's simplify this part. Since here the fraction is over 1, let's get simplify this part to become a single fraction. So the LCM is 2. It will give us 2. 2 into, divide both sides by LCM. 2 into 2, 1 times 0 to give us 64 minus 48y plus 9y squared. 2 into 1 is 2. 2 times 3y squared gives us plus 6y squared. And this is equals to 56y minus 21y squared over 2. So if we divide both sides by 2, these two multiply here, these two multiply. That's not cross multiply, rather not divide. Cross multiply both sides by 2. Since it's now an equation, these two multiply here, this will multiply here. You know, the 2 will cancel out, so our fraction will become 64. So we're going to have 64 minus 48y plus 9y squared. 9y squared plus 6y squared will give us 15y squared plus 15y squared is equals to 56y minus 21y squared. So let's call it like terms. This will be 64 minus 48y. This one cross will come over to give us minus 66y plus 15y squared plus 21y squared is equals to 0. 64 minus 48 minus 56. 48, 56 equals 614. 4 plus 5, 9 plus 1, 10. 104 minus 104y plus 1521. 1521 6 to 36 plus 36y squared equals to 0. At this point, let's reduce it. We can reduce it further by dividing by 2. So divide through by 2. Divide through by 2. The result in 32 minus 104 divided by 2 gives us 52 minus 52y plus 18y squared equals to 0. So now we have a quadratic equation, so let's rewrite it. 18y squared minus 52y plus 32 is equals to 0. If you look at this, we can see that we can still reduce it further. So reducing further, we're going to have, alright, so let's divide 3 by 2 and give us 9y squared minus 9 into 52, 9 into 5, so 2 into 5 will give us 2, 2 into 5 will give us 2, remember 1, 2 into 12 is 26, 26y, into 32 plus 16 equals to 0. So we factorize this expression. We come here. Where do we come to? Okay, let's come over here. Factorize 9y squared minus 26y plus 16 equals to 0. So multiply this together to give us this plus 9 times 16 will give us 144. So we have to look for the factors of 144. Factors of 144 will give us 72 times 2, 12 times 12, 18 times 8. Okay. So now, since this part has y and 9y squared times 16 will give us 144y squared. So we're going to use our factors, include sign and variable y. So let's see if 72, since here is positive, it shows that, and yes, negative, that means it was minus times minus. So let's try minus 72 times minus 2. This will give us plus 144. Oh no, let's do it this way. Minus 72 y times minus 2y plus 144y squared. Y squared plus 144y squared. But minus 72 minus 2y, so 2y will not give us, this will give us minus 74y, and this is not what we have here. So these two factors are out. So these two are out. Let's try minus 12y times minus 12y plus 144y squared minus 12y minus 12y plus minus 24y. But we have minus 26y, so these two factors are out. Minus 18y times minus 8y plus 144y squared minus 18y minus 8y give us minus 26y. Why not that? These two factors will give us the sum of the factors of 144y squared will give us minus 26y, and the product of the factors will give us plus 144y squared, which is what we have here. So we put these two in place of this in our equation. So 9y squared minus 18y minus 8y plus 16 is equal to 0. 9y squared minus 18y minus 8y plus 16 is equal to 0. Factor out 9y, y minus 2 minus 2 minus 2, it will give us minus 2, that's common, minus 4 minus 4 minus, okay, minus 8 minus 8 y minus 2 equals to 0. y minus 2 minus 8 y minus 2 is equals to 0. So come here, 9y minus 8 and y minus 2 is equals to 0. So say either 9y minus 8 is equals to 0 or y minus 2 is equals to 0. 9y is equals to 8 or y is equals to 2. So y is equals to 8 over 9 or y is equals to 2. Okay, but this is not our final answer because we got a simultaneous equation and we've only gotten the values of y, so we need to get the values of x, and to do that we need to use equation 2. So from equation 2, from theory x is equals to 8 minus 3y over 2. X is equals to 8 minus 3. Y is 8 over 9 over 2. Or x equals to 8 minus 3. Y is 2 over 2. Okay, so come over here. X equals to 3 times 8, 24 divided by 9. Or we say 3, since 3 here, 3 can go into 9, that will give us 8 over 3. So 8 minus, well, let me just go this way, 3 times 8, 24. So we have here 8 minus 24 over 9 divided by 2. Or x is equals to 8 minus 3 times 2, 6 over 2. So let's simplify this part. This is a fraction. Let's move it here. 8 minus 24 minus 1 is 1 minus 24 over 9. So that's is 9. 9 into 1 is 9. 9 times 8 is 72. Here 8 over 1 minus 24 over 9. LCM is 9. 9 into 1 is 9. 9 times 8 is 72 minus 99 is 1. 1 times 24. 24. So we have 72 minus 24. 12 minus 4 is 8. 6 minus 2 is 48. This gives us 48 over 9. Okay, so x is equals to x is equals to 48 over 9 divided by 2 over 1, which is equals to 48 over 9 times 1 over 2. 2 here, 1, 2 here, 24 is equals to 24 over 9, or x is equals to 8 minus 6 is 2. 2 divided by 2 is 1, or x equals to 1. Therefore, x equals to 1, or 24 over 9. Y is equals to 8 over 9, or 8 over 9, or 2. Let's look at this one. I think this can be reduced for the 3 into 24 is 8, 2 into 9 is 3. So x is equals to 8 over 2 in the lowest form, 8 over 2 or 1. Or x is equals to 8 over 2. The matrices P and Q are 1, 3, 4, minus 1, 2, 5, minus Q, minus 2. Where K is a constant. E says find PQ. Let's find determinants of the matrix PQ. Before we can find determinant of matrix PQ, we have to first of all get matrix PQ. So first, determine PQ. So PQ is equals to 1, 4, 2, minus 1, Q, minus 3, 5, minus 2, minus 4. 1 times minus 2 is minus 3. 3 times 5 plus 15. 1 times minus Q. Minus Q. 3 times minus 2. Minus is 4 times minus 3. Minus 12. Minus 1 times 5. Minus 5. 4 times minus Q. Minus 4. K. Minus 1 times minus 2. Plus 2. Which is 3. Minus 3 plus 15 is 12. Minus 12 minus 5 minus 17. Minus Q minus 6 minus 4 Q plus 2. This is our matrix. Then the determinants of PQ. Next, determine PQ. So PQ is equal to 12 times minus 4 Q plus 2 minus 17 minus Q minus 6 minus 17 12 minus 40 times 7 gives us minus 48q. 12 times 12 gives us 12 times 2 gives us 24 minus, let's simplify this bracket, minus 17 times minus q gives us 17q. Minus times minus is plus 17 times 6 times 6 times 7 42. 6 times 1 6 plus 4 10 102 plus 102 minus 48q plus 24. So let's open the bracket. Minus times 17q plus minus 17q minus times plus 102. The coefficient here is 1, so minus 1 times plus 102 minus 102 minus 48q minus 17q plus 24 minus 102 minus 48q minus 17q minus 48 17 8 plus 7 15 4 plus 1 5 plus 1 6 minus 65q plus 102 minus 24 102 minus 24. Oh, we have 2 minus 4 will give us 12 minus 4 is 8. Now here is 9. We go from here, so it will be 9. 9 minus 2 is 78. Give us minus 78. So that's the answer to E. The determinant of matrix PQ is minus 65k minus 78. B says if the determinant of matrix PQ is equal to 144, find the value of Q. So B is equals to B determinant of PQ is equal to 144. The determinant of matrix PQ is the result of this minus 65Q minus 78 is equal to 144 minus 65Q equals to 144 plus 78 plus 78 minus 65Q equals to 14478. 4 plus 8 is 12. 4 plus 7 11 plus 1 12. 1 plus 1 2 2 2 2. Therefore Q is equals to minus 2 2 2 minus 65. That's the value of Q. If G is equals to 2 3 1 4 1 4 and P is equals to matrix P is equals to 4 3 1 minus 2. Find the determinant of matrix GP. Before we can do that, we need to get first determine matrix GP. Determine matrix GP. So GP is equals to 2 1 3 4 4 3 1 minus 2. 2 times 4 8 plus 3 times 3 9 times 1 2 plus 3 times minus 2 minus 6. 1 times 4 is 4 plus 4 times 3 12. 1 times 1 is 1. 4 times minus 2 minus 8. 8 plus 9 17. 2 minus 6 minus 4. 4 plus 12 16. 1 minus 8 minus 7. That's matrix GP. So next evaluate GP. 17 minus 16 minus 4 minus 7 equals to 17 minus 7 minus 4 16. 17 times 7 49. 4 times 1 7 plus 4 9 times minus 1 9 minus 4 times 16 will give us minus 64. That's 4 minus 4 9 minus minus is plus 64. So this will give us 119 64 minus 9 minus 4 5 1 minus 6 can also go from here. That gives 11 minus 6 will give us 5. That will give us minus 55. That's the determinants. That's right. E2 equals 5 3 2 6. The question says we should look for the value of E. We apply determinant rule. Determinant rule to both sides. We apply determinant rule to both sides. Both sides of the equation. So we apply determinant rule here, and we're also going to apply determinant rule here because this stroke bracket indicates determinant. So E times A minus A times 2 is equals to 5 times 6 minus 2 times 3. E squared minus 2E equals to 30 minus 6. E squared minus 2E. 30 minus 6 is 24. So E squared minus 2E minus 24 is equal to 0. So we're going to factorize factors of E squared minus 2E minus 24. So our AC is equals to minus 24, which means 2 minus 24E. So the factors of 24 are 6 times 4 equals 24, and 6 times 4 equals 24. Yes, 12 times 2 24, 8 times 3 24. So if we put our signs and our variable E, so let's try. Minus 6 times 4 will give us minus 6, let's say minus 6 times plus 4, that's minus 6E plus 4E. This will give us minus 24E squared minus 6E plus 4E equals to minus 2E. So this satisfies what we have here. Of course, the others, since these factors satisfy this quadratic equation, others will not satisfy it. So we pick these factors. Now we're going to put the whole of this in place of this. E squared minus 6E plus 4E minus 24 equals to 0. E squared minus 6E 4E minus 24 equals to 0. E minus 6 plus 4E minus 6 equals to 0. E plus 4 and E minus 6 equals to 0. So either E plus 4 is 0 or E minus 6 is 0. E plus 0 minus 4 or E is equal to 6. So n equals to 6 minus 4. N is equal to 6 minus 4. I mistakenly skipped number 2 while solving. So if you watch, while you're watching the video, you discover that there was a note on the screen that's number 2 was unintentionally skipped. That we're going to get that part of the video at the end. So I had to refilm and get it solved so you will have it. So let's proceed. Solution. Matrix x is to the power 3, y is to the power 3. So now this determinant. So x minus x is y is power 3 minus x is power 3 y. So we factor out the common factor. X is common. So x here we have y is power 3. Oh, sorry, xy is common. Xy, so y raised to the power 2 minus x raised to the power 2. So, but y squared minus x squared is equals to y minus x and x y plus x. That is the difference of two squares. So y squared minus x squared, the difference of two squares, and is equals to this. Therefore x, so therefore xy, therefore xy, y squared minus x squared is equals to x, y minus x, and y plus x. This is the complete factorization of this determinant.